Alrighty, so welcome to 1103 section 1. Today we're going to just give you a brief introduction to the course and talk a little bit about significant figures and metric to metric conversions. And if you could mute your mic, that'd be great. It keeps on asking me people. All right. So just to kind of recap, we will be using McGraw-Hill Connect for the course. On the official lecture notes, we're using the Silverberg 9th edition. So you need to get at the minimum, you need to get a Connect access code so that you can complete the online assignments on McGraw-Hill Connect. The bookstore has access codes. Also, you can, when you click on in Blackboard to register for Connect, you can actually it'll actually give you purchase options for the access code as well. And those joining us, can you put it on mute, please, when you come in? And so those are your options. So you can go on to the bookstore. They have access codes that you can buy, different plans, and I explained those plans in the syllabus. Or you can click on a Connect assignment in Blackboard, start the registration process, and it'll give you purchase options there. Regardless, you have to register for your Connect through Blackboard. And so make sure you get that done quite quickly so that you can get registered and start working on the assignments. So the type of assignments we'll be having, we'll have, for every chapter, we'll have a Learn Smart assignment, which is like a reading assignment. So what you'll do is you'll go through, you'll read a certain section of the chapter, and then it'll ask you some checkpoint questions, and you'll answer those. If you master those questions, you move on to the next set of topics. And so it's just a completion grade. You just go through it, you read, you answer the questions, you master those questions, you move on to the next set of topics to complete. And that's what the Learn Smart assignment is. It's kind of introducing you to the topics that will be taught in the course. So I recommend you doing this first because it kind of helps you lay the groundwork for doing the homework problems. Now the homework problems are actual numerical problems or conceptual problems that are about the different concepts in the chapter. And for the homework problems, you get 3 attempts, and each attempt is the same set of questions. So they may be slightly different because they'll change the numbers, but it's the same type of concept that you'll be working on. And for every chapter, there's a set of homework problems. Typically, they're about 16 questions. Some chapters have a little bit more when it's less math. These are just like the Learn Smart. These are due on at 8 a.m. on the day of the corresponding exam. So whenever the exam date is, 8 a.m. is when all the Learn Smart and Connect homework assignments are due. Now, the homework problems can be submitted for a late penalty. I believe it's 15% a day late. In addition to that, each week I'm going to post about 5 questions on Blackboard that are kind of like what I call weekly homework assignment to keep you on track in your progress. And so they'll be open the whole week. It's usually 5 questions posted on Blackboard that covers the topics that we'll be talking about that week. Now for this week, I haven't posted them yet because I wanted to at least go through the first lecture. But after today, it'll be posted, and they're usually due by 5 p.m. on Friday at the end of the week. And after that, you'll be able to review over those questions for practice. Then the other thing we have are Connect quizzes. So these are done on Connect, and these are timed assessments. In order to do the quiz, you have to make a 70 or better on the Connect homework to attempt the quiz. And the quizzes are majority multiple choice questions, so it kind of gives you practice with multiple choice, whereas the homework problems give you practice with short answer. There are some short answers in the quizzes, but generally they're multiple choice. And each attempt on the quiz is a new set of questions. And again, these are due at 8 a.m. on the day of the corresponding exam. So what I would recommend is, you do your homework problems. If you make your good grade on the first or second attempt, try to use the third attempt as a practice. So try to go through the homework problems without any notes or books and see if you can work out the problems. At the end, it saves the highest grade anyways, so at least you're utilizing that third attempt to do some practice, prepare you for the exam. Likewise with the quizzes, get your good grade on the quiz, but if you have some extra attempts left, try to use those extra attempts as practice for the exam. So try to go through those quizzes without any notes. Well, you shouldn't use notes anyways, but if you do it, I'm not there to monitor, but on the other attempts, try to not use anything and try to go through and see if you can answer those questions without any notes or textbook. Now that kind of gives you a gauge if you kind of understand the material or not. And so these are all the assignments that we'll be doing this semester, and then of course the exams as well. So as far as the grading, there are going to be 5 exams throughout the semester. The first one will be on September 4th, which is the foundational chemistry exam, which is kind of like if you've taken basic chemistry or high school chemistry. It's very similar to that. I'll be posting a list of topics that you can start reviewing for the foundational exam. It's also, if you've done the Alex review course, at least that's refreshed you on these topics. And then in addition to that, we have 4 other exams as well. Now, as for attendance, we'll talk about that in just a second, but it's 2% of your final grade, and we'll talk more about what the attendance is on the next slide. The final exam is 30%. It'll be comprehensive. In the past, we've done ACS exams, but this fall, I don't think we're going to be using an ACS exam. We have to, I have to talk with the other Gen 1 instructors. Quizzes are 15%, and then the homework is 10%. So that's your grading scheme. Now for attendance, like I said, attendance is 2% of the final grade. To get this 2%, you need to attend a minimum of 3 virtual sessions. So that's throughout the entire semester. So starting on Wednesday, when you attend class, sometime during the session, I'll just have one question pop up on Blackboard that you need to answer to show me that you were in attendance for the virtual session. And it's not for a grade. If you get it wrong, it's not going to count against you. It's just there mainly for me to take attendance. And so you only have to attend a minimum of 3 to get the 2% for your final grade. I recommend that you attend as many as you can because it's always good. But the minimum is 3. If you can't attend more than 3, all the lectures, video lectures, and assignments are posted on Blackboard anyway, so you'll find all the information on Blackboard. Now at this time, so when you go on to Blackboard, you'll see a couple of things. For the exams, we'll be using Proctorio, and one of the unique things about Proctorio is you have to have Google Chrome for you to get the plugin. So between now and the first exam, if you don't have Google Chrome as a browser, try to install it and get the plugin for Proctorio, because that's what we'll be using for the exams in this course. Please always check the announcements. I post a lot of announcements. So for example, our Zoom details are given for the whole week, so we'll be using the same details throughout the week. And then I usually post when I have video lectures and then how to register for McGraw-Hill Connect. So once you get your access code, what you want to do is you can click on assignments and lectures. And then here's the introduction I've posted already. If you want to review over some of the basic chemistry concepts, I posted a few review slides here. And if you go to chapters 1 through 3, you can click on homework set 1 and you can pick any of these connect assignments to click on to register for. So it doesn't matter, just click on one of them so that it'll direct you to connect and you can register for the connect. You can also click on the tutorials as well. You can click on a tutorial and it'll take you to the right place to register to. So here's where all the connect assignments are. They're in homework set 1. It tells you the due date. Again, you have to make a 70 or better on the homework in order to access the quiz. Likewise, when the weekly homework assignments are available, it'll be posted in this folder here for you to work on. And so all the video lectures that I post for chapter 1 will be in this folder. And I also have gone through and looked at for other professors material, and so I posted some other videos as well here if you want to look at some other people doing the same thing. Let's see. Link to the syllabus. I believe that's everything. So let me pause. So in this question, I've given different numbers. I want to see how many significant figures does each number have. And if you remember from your previous chemistry background, there are two types of numbers. There are exact numbers and there are measured numbers. And exact numbers are numbers you can obtain by counting or by conversion factors within the same system of measurement. For example, metric to metric, English to English. So like 1 liter is 1,000 milliliters, that's exact. Or 12 inches in 1 foot, that's exact. The only one that was metric to English that you might know that's exact is 1 inch to 2.54 centimeters. So that's exact numbers. The other type of numbers are measured numbers, and that's where you have significant figures. And measured numbers are obtained by a measuring device. So here in the first number, we have 0.004073, and it's nanoseconds. So we want to know how many significant figures does this number have. And since it's seconds or nanoseconds, it's a measured quantity time, so you have to measure it. And if we look here, these zeros in front of the first non-zero number are insignificant because those are called leading zeros. All non-zero numbers are significant. So the 4, the 7, and the 3 are significant figures. Now this 0 here between the 4 and the 7 is significant because it's what we call a captive 0. So this number has 4 significant figures. Next we move on to B. We've written something in scientific notation, 8.500 times 10 to the 8th. Now here, any number written in scientific notation, all the digits are significant. So this would also have 4 significant figures. So whenever you see a number written in scientific notation, you know that all the digits given are significant. Next we have 55,000 protons, and again, this was kilogram, the unit for B, and kilogram is a gram is a measured quantity. So this is a measured number. Now we go to C. C is 55,000 protons. And at first glance, you may say, well, hey, this should have 2 significant figures. But you need to look at the unit here. We're saying what we're measuring or the number is number of protons. And so the number of protons is something you can count. So you can count the number of protons that you have. And so this is actually an exact number. And so exact numbers have infinite number of significant figures. So if you look at the unit and it's something you can count, like protons, atoms, grains, eggs, whatever you want. If you can count it, it's an exact number. Next, we go to 6,000 pounds. Pounds is a measured quantity. And so notice here we have a 6, which is significant, and then we have 3 zeros. So these 3 zeros are not significant because there's no decimal point at the end. So these are called place-holding zeros. And since there's no decimal point, these zeros are insignificant, so this would have one significant figure. And then lastly, we go to 11,650 centimeters. Again, centimeter is a measured quantity. So again, the non-zero digits are significant, so the 1s, the 6, and the 5. Now notice here that this number has a decimal point. So since it has a decimal point, that 0 is significant. So this would have 5 significant figures. Now F is a little bit different. F is when we're measuring something. So here we're measuring this line, and we want to know how many significant figures are in the measurements of this line. And so for measurements, you know, significant figures includes the certain digits plus one uncertain digit. And for measurements, certain digits depends on the tick marks of the measuring device. So you look at the smallest tick mark on your measuring device, that'll tell you how precise you can get the certain digits. So here we notice this ruler is in centimeters, and the smallest tick mark is 0.1 centimeters. So we know for certain that it is 3 centimeters. We know that for certain. And depending on where you think this red line lies, let's say it lies here, we know for certain that it's 3.1 centimeters. So that's our certain digits. So our certain digits are 3.1. These are the certain digits. Now we have to estimate the uncertain digit, and this is based on the observer. And so you would estimate to the right of the last certain digits placeholder. So since the certain digits go to the 10th, the estimated digit should be in the hundredths place. And this is an estimated digit. So what I call it, what I may estimate may be different than what you estimate. So it's, you know, this could be different. The certain digits are the same, but the estimated digit would be different. So for me, I would say this would be 3.18 centimeters. So regardless if you put 3.18 or 3.17, or you could have put 3.20, this measurement would have 3 significant figures because it contains the certain digits plus one uncertain digit. So the more precise your measuring device is, the more significant figures you would have in your measured number. And so on that note, so before we begin metric to metric conversions, it's important to know the metric prefixes. And I'm in your book, and you can find it online, there's lots of tables with metric prefixes. Some of the common ones that we use in chemistry, for example, kilo, deci, centi, milli, actually micro, nano, pretty much all of these, but I'll explain a few. So kilo, of course, we use for distances, kilometers, for mass, kilograms. And we all know that 1 kilogram is 1,000 grams. That's what the multiplier is. It's the multiplier of the base unit. So if you're looking at grams, it would be 1 kilogram is 1,000 grams. Deci is typically used, we use it a lot in volume, for example, deciliters. So there are, for example, in 1 deciliter, there's 0.1 liters, or you could say that in 1 liter there's 10 deciliters. So there's 2 ways you can look at the multiplier. One way is you could say for example, 1 deciliter is 10 liters, or not 10, that's my bad. 1 deciliter is 0.1 liters, which is what's given here, or you can, sometimes you'll see it as 1 liter equals 10 deciliters. Either way is acceptable. It's just depending on what you define as 1. So you may see it written both ways depending on what tables you look at. So centi and milli we use a lot in the lab for centimeters for measurements and length. We use a lot for milliliters for measuring volume. Micro typically we use for solutions, so we'll say a micromolar solution. Now the last 3, nano, angstrom, and pico, are used quite a bit, especially when we get to chapter 7, because those are usually units for bond lengths and wavelengths. So we talk about wavelengths in nanometers or picometers, bond lengths in nanometers, angstroms, picometers. So those last 3 are used quite a bit when discussing bonds in molecules and compounds. So now we'll look at a few conversions. And so it's very important to know these metric prefixes. So we have first we're going to start out with a few just normal metric to metric conversions. So here we want to convert picometers to centimeters. And again, let me work through this and then I'll pause it and we can ask questions if you have. So the first thing you need to know is the conversion factors for picometers to meters and centimeters to meters. So the way I do this, and there's different ways you can approach this, but if you find a different way that works, that's fine. I'm going to go from picometers to meters to centimeters. And the cool thing about metric to metric conversion is if you set it up right, you don't really need a calculator to do it. It's less error if you don't use a calculator, because if you don't use the correct parentheses, you can mess up your orders of operation. So we know that 1 picometer is 10 to the negative 12 meters, and we know that 1 centimeter is 10 to the negative 2 meters. So these are the conversion factors we need to go from picometers to meters. So let me draw my, what they call train tracks. And so since we're starting with picometers, in the conversion factor with picometers goes on the bottom and meters goes on top. And then since we're at meters here, when we're going from meters to centimeters, the meter goes on the bottom and centimeter goes on top. And if you did it right, everything should cancel except centimeters. So the picometers cancel and the meters cancel. So before we do the operation, one thing you should look at is we're going from picometer to centimeter. And pico is smaller than centi, so since we're going from a small metric prefix to a large metric prefix, our exponent power should decrease. So when we get the final number, the exponent power should be less than 14 if we did it correctly. Now the cool thing about exponents is when you multiply 2 numbers, you add the exponent. So 10 to the 14th times 10 to the negative 12th is 10 to the 2nd. Because when you multiply, you add exponents. So 10 to the 14th times 10 to the negative 12th, you add 14 minus 12, you get 2. And then when you divide, you subtract. So 10 to the 2nd divided by 10 to the negative 2. Since it's negative, it's 2 minus a negative 2. So our answer would be, here, let me write it in 2 steps. So we get 2.3 e to the 2 divided by 1 e to the negative And this becomes, when you divide, you subtract the exponents, it becomes 2.3 e to the fourth centimeters. Because again, e to the 10 to the second divided by 10 to the negative 2 would be 2 minus a negative 2 would give you 4. Now we look at the next one. We have convert 3.15 times 10 to the fourth. That's actually decaseconds to nanoseconds. My bad. It should be seconds. And so dA is the symbol for deca. And again, what we're going to do is we're going to take decaseconds, convert it to seconds, convert it to nanoseconds. So we need the conversion factors for this. So 1 decasecond is equal to 10 seconds. And 1 nanosecond is equal to 1 e to the negative 9 seconds. So now let's draw our train tracks. And so we're starting with decaseconds. Since we're starting with decaseconds, in our conversion factor of decaseconds to seconds, the decasecond goes on the bottom and seconds goes on top. And you can write 10 seconds as, if you want to write it in scientific notation, you can do it 1 e to the first seconds. Or you can put 10, it's the same thing. So now we have seconds. So in the next slot, since we're going from seconds to nanoseconds, we put seconds on the bottom and nanoseconds on top. And now you'll notice everything cancels out except nanoseconds. And so here when we multiply, we add exponents. So 10 to the fourth times 10 to the first is 10 to the fifth. So here if we do it in 2 steps. So we do the top part first, we get 3.15 e to the fifth, and then we still have 1 e to the negative 9. So before I finish this part, what we got to notice, decasecond is a bigger metric prefix than nanosecond. So since we're going from a big prefix to a small prefix, our exponent should be greater than 10 to the fourth. And so when you divide, you subtract the exponent. So 10 to the fifth divided by 10 to the negative 9 would be 5 minus a negative 9. So that would be 3.15 e to the 14th nanoseconds. So on this note, so in these two examples with metric to metric conversions, here we're going to convert squared units and cubed units. So again, in the first example, we want to go from micrometers squared to femtometers squared. And so again, the way we're going to do this, and since I don't have the Greek symbol micro, I'm just going to use U. So we have micrometers squared. We're going to go to meters squared. And then we're going to go to femtometers squared. But you may ask and look and say, well, on that chart, they don't have the squared conversion factors. Well, that's okay, because we know the normal conversion factors. So we know 1 micrometer is 1 e to the negative 6 meters, and 1 femtometer, 1 e to the negative 15th meters. So we know this. So what we're going to do is we're going to take these and we're going to square them. So we're going to take these conversion factors and square them. So whenever you square an exponent, you just multiply that exponent by 2. So what we get now is now 1 squared is 1, so we get 1 micrometer squared equals 1 e to the negative 12th. meters squared, and 1 femtometer squared is 1 e to the negative 30th meters squared. So it's very important that you square the exponent. The most common mistake that students make in doing a problem like this is they just square the unit and not the exponent. So again, the way you square the exponent is you just multiply it by 2. So negative 15 becomes negative 30. Negative 6 becomes negative 12. So now we can set up our train tracks. And so first we're starting with micrometers. And since we're starting with micrometers squared, the conversion for micrometer squared to meter squared, micrometer squared goes on the bottom. Meter squared goes on top. Then now we're going from meter squared to femtometer squared, so meter squared goes on the bottom. Oh, almost made a mistake. And femtometer squared goes on top. So now you'll notice that all the units cancel except femtometer squared. So again, when you multiply, you add exponents. So 10 to the 8th times 10 to the negative 12th would be 4.37 e to the negative 4. And then we have 1 e to the 30th, negative 30th on the bottom. So when you divide, you subtract the exponents. So negative 4 minus a negative 30, this would be 4.37 e to the 26 femtometers squared. And this makes sense because we're going from micro to femto. This is going from a relatively large metric prefix to a smaller metric prefix, so our exponent should go up, and that's what it did. And then lastly, we want to convert decimeters cubed to nanometers cubed. This will be the last one. So we have decimeters cubed. We're going to convert it to meters cubed to nanometers cubed. And so we know that 1 decimeter is 1 e to the negative 1 meters, and 1 nanometer e to the negative 9 meters. So just like we did with the squared, we're going to have to cube each one. So again, when you cube, you multiply the exponent by 3. So we get 1 decimeter cubed and 1 nanometer cubed. So now that we have our cubed units, or cubed conversion factors, we can do our train tracks. So we're starting with decimeters cubed. Since we're starting with decimeters cubed, it goes on the bottom in our conversion from decimeters to meters. And then when we're going from meters cubed to nanometers cubed, meter cubed goes on the bottom. And nanometer cubed goes on top. So now when we multiply, we add exponents. So 10 to the negative 3 times 10 to the negative 3 that would be -6, so that'd be 6.8 e to the -6, and we have to divide it by 1 e to the -27. So again, when we divide, we subtract the exponents, so -6 minus a -27 would give us 6.8 e to the 23rd nanometers cubed. No, wait, that's not right. Let me undo that. Made a boo-boo. Let's see. 6.8 e to the 21st nanometers cubed. Yep. And this makes sense because we're going from, again, a large metric prefix to a smaller metric prefix, so our exponent should increase. And since we're cubing it, it would increase quite a bit.